Hi everyone, my name is Kevin, and I want to walk you through today a tutoring example using an AP Calculus AB problem. Now, like I've mentioned in my other videos, during our actual tutoring session, it'll be much more of a discussion. I'll be asking you lots of questions and we'll be working on the problem together. Today, I'm going to walk you through how I think through the problem and a little bit about my process as well. So for today's problem, we are looking at an actual problem from a public practice exam that the College Board released back in 2012 for AP Calculus AB. Now, the topic that this covers is analytical application of differentiation, determining intervals on which a function is increasing or decreasing. So let's read the problem here. It says, let f be the function given by f of x equals 300x minus x cubed. On which of the following intervals is the function f increasing? As we can see, it's a multiple choice problem where we need to choose the interval or intervals on which this function is increasing. So first, let's start by listing out, hey, what are the things that you need to know or to be able to do to actually solve a problem like this, right? First thing you need to be able to do is you need to know how to calculate a derivative. In this case, using exponential rules. What else do you need to know or be able to do to actually be able to solve this? Second thing is I need to know not just how to calculate a derivative using exponential rules, I also need to understand that relationship between a derivative and slope. All right, it's not enough that I can calculate a derivative. I also need to understand, hey, what does that derivative tell me about slope? And that will help me answer this problem. Now, like I mentioned in other videos as well, we won't necessarily list out all the knowledge needed and skills needed before every problem. Although if it's a fit for your learning style, we absolutely will. The reason I do this is I want to show you, hey, I have thought through what are the things that a person needs to know or be able to do to be able to solve these problems. And then what that lets me do is then tailor each session to exactly where you are. So I'll ask you questions and assess kind of what your understanding is across the things that you need to know and do. And if we see that there's any gaps, that's where we can focus. And if we also see that, hey, you actually have mastery of it, we can go at a little bit of a faster speed. Right? So by having this understanding of, hey, what are the things that you need to know and be able to do, we can really tailor these sessions, hone in on those areas where you might have any gaps, and also go at a pace then that also acknowledges those areas where you might already have some mastery. Okay? So with that in mind, let's go ahead and go through this problem. We have a function here, and it's asking us on which interval is this function f increasing. All right, well, the first thing we need to know is, well, if we're thinking about increasing and decreasing, we should know that, hey, that has something to do with slope, right? The slope of the graph, if it's increasing, is going to be positive. We also know the slope of the graph when it's decreasing is negative, right? Let's actually just go ahead and sketch out a really just random graph here to help make that point, right? If we look at this graph here, we can see the slope is positive in these areas where it's increasing and it's negative in those areas where it's decreasing. And we'll see here again, I'll look at that, positive slope and it's increasing. Now, why does that matter? That matters because we know that we can figure out what the slope is of a function if we know how to calculate the derivative, right? And what specifically do we know about that? Well, we know that, hey, when the derivative of this function is equal to 0, what does that mean? Well, that means we have 0 slope, right? So that's these points here, where you're not increasing or decreasing. You have 0 slope, right? What else do we know about that? Well, we also know if f prime of x, or our derivative, is equal to a positive number, right? So for any x value where we're getting positive value, we know that that means that we have increasing slope. And for any values of x, where we are getting a negative value when putting that into our derivative, we also know that that means that we're getting decreasing slope, where the slope is going downwards. All right? So how do we use that information then to figure out the intervals in which this function up here is increasing or decreasing? Well, let's go ahead and start with that first thing we know, which is, well, whenever that derivative is equal to 0, we know that we have these points, this one right here and this one right here, where we have 0 slope. So let's go ahead and determine where we have 0 slope for our function. Okay? So we have f of x is equal to 300x minus x cubed. All right? And we want to figure out when is our first derivative, f prime of x equal to 0. Well, first let's go ahead and figure out, well, what is f prime of x? What is our derivative of this function? And the way we're going to find the derivative of this function here is we're going to have to use some exponent rules, right? So what's going to be the derivative of 300x? Well, that's just going to be 300. What's going to be the derivative of negative x cubed? Well, we bring that exponent out to the front. We have negative 3x. Subtract 1 from our power there, and we have squared. Right? So we know that the derivative of this function is 300 minus 3x squared. Now let's figure out where that slope or that derivative is set when we set that equal to 0. At what values of x do we have 0 slope? So let's set this f prime of x equal to 0. And we have our derivative here. And let's just solve. Let's bring that 3x squared to the other side. All right. I'll divide both sides by 3. So x is equal to, remember, plus or minus 10. All right, so what is this telling me? This is telling me, hey, for the graph of this function right here, I know that at negative 10 and 10, I'm going to have 0 slope. All right, now let's just take a second to think through, well, why is that so helpful to figure out increasing and decreasing when I know where my slope is equal to 0? Well, what you'll notice here, if I were to look at this very first point where I have 0 slope, what you'll notice is, hey, when you look at what's going on between any points of 0 slope, right? So I'll look at these two. You'll notice that, hey, between those 2 points where you have 0 slope, the graph is only doing one of 2 things. It's either increasing the entire time or it's decreasing the entire time. Right? Let's even point out another one. You've also got 0 slope here. If I were to take a look between, well, what's happening between this point right here and this point up here, well, it's only doing one thing, it's increasing. If I look between this point right here and this point right here, it's only doing one thing, it's decreasing. All right? So what that helps us set up is actually figure out, well, what are the intervals over which the graph is either just increasing or just decreasing? Okay? So for our example down here, we know that our 0 slope happens at negative 10 and 10. So I'm going to go ahead and set up some intervals. Okay. First interval I'm going to set up is negative infinity to negative 10. And we'll take a look at the graph to see why we're setting it up this way. All right. My next interval I'm going to set up is from negative 10 to positive 10. Okay, and the last one that I'll set up here is from positive 10 to infinity. Right, now why are those the intervals I'm going to set up. Let's go ahead and look at this graph here. So I know that at negative 10, and the scale here isn't going to be perfect, but let's say that this is negative 10 here, and let's say that this is positive 10 right here. What do I know about these points because we did the first derivative and set it equal to 0? I know that at these points, the graph of this function is going to be, or the slope of the graph of this function is going to be 0, which means all throughout this area here, it's either going to be positive or negative slope. I don't know what it's going to be yet. From this entire range right here between negative 10 and 10, again, it's going to be either positive or negative slope, just one of the two. And the same thing right here. For this interval right here, I know that it's all going to be positive or negative slope, right? Because I know at negative 10 and positive 10, we have 0 slope, so those are going to be the 3 ranges. Right, so those are the 3 ranges I set up: negative infinity to negative 10, negative 10 to 10, and positive 10 to positive infinity. Right, so I have my 3 ranges set up. Now I got to figure out, well, what is happening within those ranges or those intervals? Is the slope of my graph increasing or decreasing? Right? So let's figure out, well, how do we figure that out if it's increasing or decreasing? Right, so are we increasing or decreasing? Well, what do we know, again, about our first derivative? We know that when we plug an x value into our derivative and it gives us a 0, well, we know that means 0 slope. But we also know if we plug in an x value into our first derivative and we get a positive number, it means that our graph is increasing. And if we plug an x value into our first derivative and the value is negative, that means our graph is decreasing. So what can we do? We can actually just plug in a number within each of these intervals to figure out, hey, is this increasing or decreasing? Right, so our first interval, we have a lot of numbers to choose from, everything from negative infinity to negative 10. Let's pick something relatively simple. Let's pick negative 20 to plug into our first derivative. All right, so if I plugged in a negative 20 into here, let's do f prime of negative 20. Okay, so that's going to be equal to 300 minus 3 times negative 20 squared. All right, if you do the quick math there, you have negative 20 squared, that's 400. 400 times negative 3 is negative 1200. You're going to get negative 900. All right, what kind of sign do we have on this number? It's a negative, so what does that tell us? Since we plugged in an x value and it's giving a negative number when we're plugging into our first derivative, that means the slope of our graph then is negative. The graph of that function on that interval is going down. It's decreasing. It's negative. Now let's do the same thing quickly for the other intervals as well. Negative 10 to 10, something really easy. Let's just plug in a 0. That's within that interval. So what is f prime of 0? That's going to be 300 minus 3 times 0 squared. Okay, great. 300 minus 0. That equals 300. More importantly, that's a positive number. So I know that my graph is going to be increasing on that interval. And then finally, for our last interval, if you went ahead and plugged in, let's say, a positive 20 for our last interval, you'll see that you get a negative number. All right, so there you have it. We figured out what the intervals would be by figuring out where we have 0 slope. We tested numbers within each of those intervals to understand, hey, is our graph increasing or decreasing? And we found that it's within this interval here from negative 10 to positive 10 where we're going to have positive slope, which means that our graph is increasing. Right? So if we look at the question here, it asks, on which of the following intervals is the function f increasing? That's going to be b, negative 10 to 10. Now, if we wanted to go ahead and just look at what the graph of this looked like, if you plug this into your graphing calculator, just so you can kind of see, it's going to look something like this. This is not going to be perfect scale, but the graph essentially will be something like that, right? Well, you'll actually see, hey, from that interval from negative 10 to 10, yes, in fact, you are increasing, positive slope.